boundary angle is. Okay, what are boundary angles? So if I look at sine 90 degrees, it's exactly here, isn't it? There's no related angle. No related angle. Which means that I can't really calculate it using the method I outlined to you before. And when it's 90 degrees, is it in the first quadrant or is it in the second quadrant? It's hard to tell. It's on the boundary, isn't it? So angles like 0, 90, 180, etc., these are called boundary angles because it doesn't really belong to a quadrant. Boundary angles. And it doesn't have a related angle. So it doesn't have no related angle, no quadrant. It's on the boundary. So the way we do them will be slightly different from the way we do other angles. Okay? And in fact, they are not as high as the other angles. They're actually easier. You will see why. Okay, so we're going to work out what sine 0 is, cos 0, and tan 0. So going back to our earlier definition, sine 0 is the y value, isn't it? Cos 0 is the x value. And tan 0 is y over x. That's what they mean. So if I know the x and y values, then I could work out what the value is. So going back to this unit circle, we can get the corner of these boundary angles. Let's work out the points. What will be the corner of these points? Let's look at the first point. What's the corner of this point? Well, to get to that point, what do? You have to go 1 across, 0 up, so write 1, 0. How about the corner of the other point? Jeremy? Well done, good. Christina, what's the next one? Good. And then Nat, what's the one at the bottom? Yes, very good. Alright, now I could work out these angles. Alright, let's start with sine 0. Sine 0 is exactly over here. Right, that's the ray, 0 degrees. So what sine 0 is y. And the y is 0, so you write 0. Okay, that's your y. And how about cos 0? Cos 0 is x. X is 1. And to get tan 0, you do y over x, which is 0 over 1, which is 0. Let's verify that with the calculator. If you press sine 0, you will get 0. And if you do cos 0, you will get 1. If you do tan 0, you get 0 again. Okay? So it makes sense. Now, you can then do all these questions with this circle. So sine 90 will be, again, y. What's the y value? 1 now. Sine 90 is 1. What's cos 90? Cos 90 is x. So what's cos 90? It's x, which is 0. And then to get tan 90, you have to do 1 over 0, isn't it? X, y over x. What's 1 over 0? Nothing. So is it 0? Can you do 1 divided by 0? We can't divide by 0, so that means you get undefined. Math error. If you do tan 90, you do get math error. Right? Math error. So you say it's undefined. That's why you get error, undefined. Alright, remember you cannot have 0 in the denominator. Let's keep going. Sine 180. Katie? Sine 180. 0, yes, because the y value. And then Emmy, cos 180. Minus 1, x, yes. Cos 180 is this number. And then Anthony, tan 180. 0, yes. 0 over negative 1, which is 0. Very good. Alright, let's move on to 270. Okay, Julia, what's sine 270? Negative 1, very good. And then Katrina, cos 270. 0, good. And then we're going to do tan 270. Tan 270, let me ask Marjolaine. Undefined, yes. So you get 0 in the denominator, you say undefined. phi. Okay, good. All right, next one, sine 360. Anika, what's sine 360? 0. Yep. Now we all know how it works. Cos 360. Who else have it? Kira? 1. And then the last one, who haven't asked? Can I ask everyone? Oh, no. Bailey. 0. Yep. Okay, good. All right. That's good. So you all know how it works. It's actually easier, right? Boundary angles. Let's move on. Next page. Actually, we'll go back just in case you're still copying. So that's what we did. Yep, hopefully you're finished. All right, let's move on to the next page. Okay, next page, there's some more identities. And these are not hard to learn. They are very easy. They are related to the quadrant. You will get some of these questions in the textbook homework. If you can't do them, we'll go through them. Now you know how it works. Okay, so let's start with, okay, good. All right, so we have to understand what that means. To simplify this, we just have to let theta to be an acute angle. So we're going to draw here. That's theta, right? That's theta, isn't it? We're going to call that theta. And why do I let theta here? Because this angle here will be exactly 180 minus theta. So that's why I set the theta there, so that this angle become, if we start from the from 0, it become 180 minus theta. And in that case, we sense that this is like a second quadrant. And in the second quadrant, all stations to central, only sine is positive, everything else is negative. So you write sine, that's equal to sine theta of the related angle, that's equal to cos theta, that's equal to negative tan theta. Okay? So that's how we get the value of this using the quadrant. Right? So you can think of the theta as like a related angle. Like, but not, doesn't have to be a related angle, but it's like a related angle. Okay, so that will help you to memorize these rules. Okay, how about 180 plus theta? Well, think of 180, and then if you plus theta, it ends up in the third quadrant, isn't it? Right? So this is like the third quadrant. And the third quadrant, only which one is positive in the third quadrant? Tan. So everything else is negative. So right, sine theta, cos theta, but positive tan theta. You don't really need the positive sign. Okay, like that. Okay, good. Let me rub this off a bit so it's clearer. Cos. Okay, and then we've got two more to go through. The next one, 360 minus theta. All right, which quadrant will it be? It's in the fourth, right? Because you can go 360, right? And then minus theta means you go backwards, right? So that angle becomes 360 minus theta. And then you can think of that small angle as the related angle, right? Okay, so you will see that's in the fourth quadrant. You'll see, say that this is going to be negative for sine, negative for tan, but positive for cos. So write negative sine theta, and this is negative tan theta, and that's cos theta. Okay. All right, how about the last one? What does negative angle do? Which way does it go? It goes in the clockwise. But the related angle is still theta. So you can think of, so in the third quadrant, like fourth quadrant like before, these two are negative, cos is positive. So you write equal to sine theta, tan theta, but positive cos theta. All right, good. And then we'll continue. All finished. All right. Next one, how about these ones, 360 plus theta? So you just have to go around in circle plus a little bit more. So it ends up in the first quadrant again. So in that case, everything's going to be positive. So you say that's going to be sine theta, cos theta, tan theta. Everything's positive. Right, so these are the sum of the identities. And they are not hard to learn. Yeah, you just have to draw a unit circle. Alright, done. So some of the homework questions will contain this, so now you know what to do. Right, the next thing we're going to do today is graphs. So what happens if we graph this function on a number plane? See what graphs we get. Okay, so we'll go to the next page. You do need a calculator for this. If you don't have a calculator, come to the front to borrow one. So get out your calculator and press the button. So what do I do to the first one? You do sine 0. What sine 0? We learned from before is 0, isn't it? Oops. Equal to 0. So what you do is you write 0. The next one, sine 30. Oops. Sine 30. Sine 30 is, press the wrong one. Sine 30 is half, 0.5. And you round to one decimal place where necessary. So the next one, sine 60, you get 0.9, right? 0.9. The next one is 1. And then you just finish it. And then I think 0.9 again, etc. Okay? Finish that off. So use your calculator. Under place, yeah, because it's hard to draw. Actually, maybe you can write it as 0.8. What was the number? 0.87. So slightly lower than 0.9. 87. Okay, next one, 150. 150 is 0.5, right? And you get 0 again. And then after that, you get negative 0.5. And then use your calculator, you get negative 0.87, negative 1, negative 0.87, negative 0.5, and then 0. Okay, so you just use your calculator. You see all the values repeat due to the symmetry of the unit circle. So you plot the point. So remember 0, we're going to plot the ratio against the angle. Start from 0. The next one is 0.5. The next one is 0.87. Which is 0.87 will be slightly below 0.9, slightly. And the next one is 1, and then over here, over here, over here, over here, there, 0.87. Yeah, slightly below this point. Alright, so you get this, all the dots, which you will join. If you use a pencil, that will help you. So if you make a mistake, you can rub off. So you join the dots. You get what we call a sine curve. That look like this. Okay? Alright, join the dots, you get a sine curve. Alright, I leave you to finish the cos curve. So do the next graph as well using a calculator. See what graph you get. Alright, and then while this is happening, I'll try to find something that's relevant on things in the year 10 book. Yeah, possibly I did. So let's continue. Alright, so now we do the cos graph. So cos graph we start with 1, 0.87, 0.5, 0, negative 0.5, very hard to write, negative 0.5, negative 0.87, -1, -8.7, -0.50, and then 0.5, 0.87, and 1. For the points, you get the graph slightly below. Alright, so you plot the points, you get a different graph. Okay, so we get what we call a cos graph, which looks similar to the sine graph. Alright, so you get that. That's your cos graph. Okay. So you see these graphs, you should memorize them, but I'll show you a quick way of memorizing them. As you can see, completing this table of values can take long in the test, so we have to simplify this process. But you just have to remember the shape. Okay? And there's some question you want to ask about the graph soon. Yep, okay. So I'll just give you one more minute to catch up. So let's look at animation to see how this works. So we'll go back to here. See, that's a sine graph. Now, what's the definition of sine again? It's equal to? No. Y. Because remember, cos is alphabetically in front of sine. C is before S. So cos is X, sine is Y. So if I'm going to play this, remember we're going to graph the Y value of this unit circle as the angle increases. So watch this. So it's going to go up. See the Y value? It's increasing to 1, isn't it? Right? So the length of this red bit is now graphed against the angle. And if I continue, what happened to the Y value? Start to decrease to 0 again. Like that. And in the third quadrant, it becomes negative. And then after that, it becomes still negative, going back to 0 again. And then it repeats, right? After 360, it repeats. Okay? Now let's look at the cos graph. We'll click on this. Oh, how does it work? Let's all right, okay. So it's the x value. So it starts from 1, becomes 0, and then the x value starts to increase again, but becomes negative. To negative, and then to there, and then to there. Okay, so that's how the graph comes. I won't look at the time graph. We'll focus on the sine and the cos first. You'll see the red graph that's been shifted, isn't it? So if I move the sine graph to the left 90 degrees, you become the cos graph. Right? Okay, good. All right, so we're going to go back to our notes. All right, we're going to answer a few questions. So there's some question we're going to answer. It's still recording, good. All right, what values of theta is sine graph negative? When is it negative? Yeah, it becomes between 180 and 360, isn't it? And that's exactly corresponding, yep, come in. Exactly corresponding to the first, second, and third quadrant as we expect, isn't it? In the third and fourth quadrant, sine is negative, right? Which corresponds to third. You're sitting there, next to Jeremy. Yep, third and fourth quadrant. Everyone, I don't want him to sit in the corner. Okay. Yeah, but he's going to sit in the other corner. Okay, next one. Okay, so we got the sine graph, and in the third and fourth quadrant it's negative. How about the next bit? How about the cos graph? What's the maximum value? What's the minimum value? Yeah, maximum is 1. Why is the maximum 1, minimum -1? Why? Yeah, because if you go back to the circle, the highest y x value could be is 1, right? It can't be more than 1. Does that make sense? That's why the graph cannot have a value more than 1, because the circle, the maximum value is 1. The radius is 1. So that's why it can't go beyond that. So we'll go back to this. Why is it so? Because it comes from the unit circle. The maximum x value on the circle, max x value, doesn't let me to write, maximum x value is less than, well, on the circle, the x value is between 1 and -1. That's why the maximum value is 1 The minimum value is -1. And what values of x is the cost graph negative? When it's a negative? Oh, that should be theta. I forgot to update. Theta. What value of theta is the cost graph negative? It's negative in the second and the third quadrant between 90 and 270. Yep. Alright, well, we'll just finish page 19, and then I'm going to show you a fast way of drawing this graph, because as you see, it takes a long time to draw it. We want to be able to draw them in under 1 minute, and in fact, maybe even under 30 seconds. That's what you should do. Okay, let's go to the next page. Yeah, you can do it in 10 seconds if you're fast, even 2 seconds. Okay, now watching. Now, you don't need all the details. You just need to remember the shape. Now, we've already seen the shape. Now, what we need to do is, you just have to get the boundary angle. And to get the boundary angle, just use your calculator. Sine 0 is 0, right? And sine 90 is 1. 1. And then just use your calculator to get the next one. The next one, 0, -1, 0. Once you do this table of values, plot the points 0, 1, 0, -1, 0. And what do? You join the dots. Of course, you do not do this. I have a magic pen that disappears, so some people like to draw a triangle. It's not a triangle. Okay, it's not straight, it's curved. Because you've seen what the graph looks like. It's curved like this. So remember this shape? So you're going to replicate this shape. Now go back to the normal pen. So you're going to go like this. Going up, go down, like this, right? Okay, so you do that. Okay, that's your sine graph. And same thing with the cos graph. Just use your calculator for this. Cos 0 is 1. You get 1. Cos 90, use your calculator. Of course, if you remember them, that's even better. You don't even need to use a calculator. That will make things faster. 0. -1, 0, 1. You get this graph. Okay, that looks like a valley. Oops. So if you draw it, you draw a valley. But again, do not draw straight. It's like this, going down slowly, fast, and then slow again. Fast, slow. Right? Something like this. Now, how are you going to get better? You're going to draw it again. Now, I told you not to use straight line. Okay? Alright, now, you can practice again. There's another one. Do example 38. Okay? Alright, try example 38. Exactly the same, but if you do it again, you get better. If you do it the third time, you get better. By the time you do it in the 10th time, you get very good. You can do it very fast, under 30 seconds. While you do this, I'll come around just to see what you're doing. Okay, just pause this. Okay, good. So, why is it frozen? Okay, I'll unfreeze it. Okay, so I'll leave the practice to you, so I won't do it again. Well, how does the graph of sine and cosine correspond to the ASTC rule in trigonometry? Now, just remember, in the first 2 quadrants, sine is positive. Next 2 quadrants, sine is negative. And same thing for cos. First and last quadrant is positive. The second and third quadrant is negative. So use that to help you to remember the graph. Okay? All right. So basically, I'll just make a small statement. So cosine, ASTC rule, because in the second and the third, it's actually negative, as we know from the unit circle, and that's positive. First, I regret you to see here, you keep looking at my stuff. Okay, so fourth and the first. Alright. Alright, so that's positive. So use that to help you to remember the graph, or use the graph to help you remember these rules, okay? Alright. Alright, now next one. Now that's the extra practice you've done already. So we'll just go on to the next page. Okay, we have to use the graph. So why is the graph useful? It's useful for another purpose, so that it can actually work out the boundary angles. So if you remember the graph, I could actually work out these. Okay, so let's try to work out these. So another opportunity for you to practice. Remember, sign is 0, 1, 0, negative 1, 0. Just remember the 1 and 0s. And then just draw the graph. See how fast I do things? It's very easy once you get used to it. So you can do it in under 10 seconds, I think. Right? And cost graph starts from 1, 0, negative 1, 0, 1. Hey, put it back. You go here, 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 here. And then you just draw. Like this. Right? The more you do it, the better you become at drawing this. And well, if you know the graph well, you can easily to do these values. So, for example, you want to find out what cos 0 is. So go to the graph. What's cos 0? 1. Sin 0. Go to the graph. Sin 0 is 0. Sin 180. Where's sin 180? Over here. 0. Get it? Now try to rest. Use the graph to help you to do the to do the question. All right. Cos 90. Where's cos 90? Over here. 0. Now we haven't done the tan graph, but that doesn't mean we can't do it. Just remember, tan is sine over cos. So we don't really need the tan graph to get the value. We just have to use the formula. Sine over cos, and what's sine 360? Sine 360 is 0. Cos 360 is 1, so the answer is 0. Okay? I'll try the next one. Of course, you can do it on a calculator as well, but we need to be able to do this without a calculator, so we know how it works. Alright, how about tan 270? Tan 270 is sine 270 over cos 270. And cos 270 is 0, and it's undefined. So you know it's undefined. Okay, like that. How about cosec 90? Cosec 90 is, what's cosec equal to? 1 over sine, okay? And sine 90 is 1, so the answer is 1. Alright, sec square means sec 180, then bracket square, which become 1 over cos 180, all square, like that. And what's cos 180? Going back to the graph, cos 180 is minus 1. So if you do 1 over minus 1 squared, that should be positive 1. Okay, next one. How about cot 90? How do you do cot? What do you do? Cos over sine, yes. Cos 90 over sine 90. Cos 90 is 0, sine 90 is 1, so it's 0. Now, what if you use another formula? What if I do 1 over tan? Would that work? Huh? It's an extra step? No. If you do cos tan 90, what's tan 90? It's undefined, isn't it? 1 over undefined. So you won't get 0. So not to use the 1 over tan formula for this, use cos over sine. Don't use this one, even though cot is equal to 1 over tan, but it doesn't work where it is 90. You have to use cos over sine to get 0. If you do 1 over tan, you get 1 over undefined. What's 1 over undefined? We don't know. So use that. Okay. Alright, next page, you will see another graph. It's the same graph. How many times have you drawn now? 5th time. Do you think you are more confident? You can go home, draw sine graph, cos graph very easily. Now draw it. I didn't even give you a table of values because you know what it looks like by now. What do? Just put 0, 90, 0, 1, negative 1, 0. Join dots, done. Less than 5 seconds now. With no table of values. How about cos graph? 1, 0, 1, negative 1, 0, 1. Okay, just remember the rhyme. 1, 0, negative 1, 0, 1. Right? This, under 5 seconds. Okay, good. We're making good progress. Okay, any question? Or draw your graph? Okay, next one. Now, we can actually use the graph to solve some equations. Let's solve the first one. Now, be careful, we're finding angles now. Stop. We're finding angles. What angles make sine x 0? When is it 0? Is 0 at x is 0. What else? 180 and 360. Pretty easy, right? So we can use the graph to work out what angle produces the ratio 0. Yeah, so when the ratio is 0, what angle would it become? 0, 180, 360. How about the next one? Cos x is -1. When is that? What angle makes the cos -1? 180, right? See this point, -1, it's 180. Okay, so far pretty easy. So we can use the graph to do ratios, also use the graph to find angles given a ratio. All right. How about the next one? What if I choose another value? Let's say half. So let's say cos x is half over here, half. Where would it cross? That's a little bit more tricky, isn't it? Because definitely the answer is not 45 degrees, because it's not really halfway, isn't it? A little bit more than halfway. We have to find out what these angles are. Okay, so what we do is when it's half, we can't use it. We can use the graph for 0 or -1 or 1, but not for anything in between, because that's a little bit more of a mystery. So we have to use a different step to do this. So this has to be done in a different way. We can't use graph. No graph. Whereas the other one, you have to use the graph. The 0, 180, and 360. Okay, so how to solve a trigonometric equations? So these are called trigonometric equations because it's an equation finding the unknown angle. Have a look at the 4 steps. First step, find the quadrant the angle is in. Draw the ray in the correct quadrants. Find the related angle. Find the actual angles in the domain. All right, let's go through this. First step, when we're given the ratio, the first step is look at the quadrant. Now, it is positive, isn't it? Which quadrant is cos positive? First and fourth, right? All stations to central. All means everything's positive. C means positive in the 4th quadrant. That's your first step. Draw the quadrant. Find the quadrant the angle is in and draw the ray. So we've done the first 2 steps. What's the next step? Find the related angle. How do you find a related angle? You just go like this. Shift cos 0.5. Let's do it on a calculator. Shift cos 0.5. It gives you 60. That's your related angle, 60. Right? So that's 60 here, 60 there. Right? Label the related angle. I've done question 3. Now do the 4th part. Find the actual angle. So that's the related angle, but it's not x yet. That's just the related. So use the related angle to find x. So x equal, in the 1st quadrant, is just the same as the related angle, isn't it? In the 1st quadrant, right? And in the 4th quadrant, what do? How do you find the angle? You have to go around to get to here, right? How do I find the green one? 360 minus 60. So you get what? 300. So that's the 2 answers they want you to find. Alright, any questions? So if you follow these procedures, that will get you the correct answer each time. Alright, now let's go back to the graph. How is that related to the graph? Well, you can see how it works from the graph. So if I look at the graph more carefully, remember the answer was 60 and 300. So let's label this so it's at 60 and 300, which is over here. Right? And it's, no, actually wrong place. Alright. Okay, remember this one? We'll try to find a question mark. It's actually 60 and 300. But you can't really read it off from the graph, isn't it? The graph only shows you 0, 90, 180, 270, 360. Any other thing in between, you have to use the quadrant and find the related angle. So that gives you 60. As you see, half is 60. Half is also 300. Okay, but not to use the graph, use this approach. No graph. Okay, same for that. Alright, okay, let's do another question as a practice. So next question is 2 sine x plus 1 equal to 0. Just like the equation, let's make sine x the subject. So 2 sine x equal to -1, and then sine x equal to -half. Okay, negative. Which quadrant is sine negative? All stations to central. Third and fourth. So third, because sine is negative, all stations to central means that it's not in here, it's not in here. It has to be in these two, right? All right, let's rub off this because it's distracting. Okay, next step. What's the related angle? Related angle. You do sine inverse. Now, with the related angle, be very careful. Even though it's negative, you never put negative when you find the related angle. You just put positive half. Okay? Never put negative because it gives you a different answer on your calculator. So if you use your calculator, you do shift sine half, which you get 30 degrees. But what if you put a negative in front? You get -30, which is not the related angle. You have to get the related angle. So make sure you put a positive 30 degrees. So write 30. The negative just tells you what quadrant it is in. It has got nothing to do with the related angle. The related angle depends on the half, not on the negative. Okay, the negative just tells you in the third and the fourth quadrant. And the last step is, once you get the related, it's very easy to do. You just have to go around in circles. So start from here. Third quadrant, you do 180 plus 30. Fourth quadrant, you go around like this. 360 minus 30. Like that. So which means your final answer is 210 degrees and 330 degrees. Alright, we've got a few more to go through, then we're done. Just the next 6 questions, so I'll let you have a try. Follow this 4 steps procedure. Maybe I'll get started with the first one. That's a little bit different. It's sec. How do you do sec? Just write sec as 1 over cos. So you get 3 over cos x, like that. And then what do? You flip it. You flip. So write cos x over 3 equal to -1 over 5. And once you flip it, get rid of the 3, so you get cos x equal to -3 over 5. Right, get the idea? So you try to make cos the subject, or sine the subject, or whatever you have. Alright, so then you follow these procedures. After you follow the procedures, you get the angle. So let's follow the procedures. First step, quadrant, it's negative. Which quadrant is a negative? Second, like this, and third, like that. All station to central. Then related. Related. You do cos inverse of positive. Now you have to round it to the nearest degree. Let's do that. So we get shift cos 3 over 5. Like that, 53.1. So just write 53 degrees. Now, the question, what if I can't be bothered, just put a negative in front? There's a problem, you get obtuse angle. That's not really related, isn't it? That's why I always avoid to put negative there, always put a positive. The negative just tells you what quadrant it lies in. Okay, so we go back, so get rid of the negative. So it's actually 53 is the related. So the related is 53, that's 53. Okay, and then you find the actual angle. Alright, so how do I find the actual angle? You have to go like this. In the second quadrant, you just do 180 minus 53. And in the third quadrant, you do 180 plus 53. Alright, so what do you get? So you get x equal to 210 33, or no, that's the second one. What's the first one? 200 and 127. All right, good. Like that, any question? All right, how about the next one? Sine x is 0. Which quadrant will it be? It's neither positive or negative. Yeah, it's a boundary angle. So when it's a boundary like this, you have to do what? A graph. So note the difference how we do these two questions. Graph, what's the sine graph? Look like this. So that's why I keep stressing, memorize the graph. That will help you to solve equations. So when it's a 0, so if you remember the 5 times we did it, you would remember these are the angles, hopefully. If not, you can go home and practice more. Like that. So when's a 0? At 0, right here, 180 and 360. So remember, when it's 0, use the graph. And in fact, use graph when sine x equal to 1, 0, negative 1, use graph. Okay? Not just for 0, 1 and negative 1 as well. Same for cos x. Use graph. Use graph. Okay? Because there's no related angle. Okay? There's no quadrant. It's on the boundary. Alright, and then try the next one. Next one, you should know what to do. Alright. Okay, cos x is negative 1. What do? You have to draw a graph, right? So negative 1, you draw a graph like this. So cos graph look like a valley, like that. So when it's a negative 1, it's exactly at 180. That's it. You don't have to do anything. It's very quick, isn't it? There's one answer, right? Now, what if tan x is negative 1? This one, you don't use graph. Okay, that's not a boundary angle. So you have to do it normally. So when it's tan negative, in the second and fourth quadrant, right? And then we'll find the related angle, related, and then work out, okay? All right, how do you get related to tan inverse of negative 1? Or positive 1, never put negative. It should get you 45 degrees. So 45, 45, right? And then you get the quadrant, get the angle. So x equal 180 minus 45. And this one go around 360 minus 45. Yeah. So you get 135, yes, and 315. Alright, and the last one, f, not the last one, just tan x is 0. That's not going to be on the boundary. But we haven't done the tan graph, but we don't need to because tan is actually sine over cos. Right? And what do? Just times both sides by cos x. If you times both sides by cos x, the cos x get cancelled. So we're solving this one. And we know how to solve it. What do? We'll draw the graph. And you have to watch a lot of videos. Sit down. Alright. And then what do? You have to draw the graph of sine like this. When's a 0? 0, 180, 360. Alright? We just need to do one more question, but not on this page, on the next page. Then I will leave the rest for next time. Because I do want you to do some practice before we go on. Maybe we'll spare another lesson on this, but anyway. Alright, good. Alright, next page. Don't worry, it's easy. Okay, so I've summarized all the methods. So whenever you see cos x is 1, 0, -1, use the graph. 1, 0, -1, use the graph. If it's tan, use sine of cos. We've just seen that from example. And cot, use cos over sine. Any other question? Related angle quadrant. Get the idea? Just have to remember some special cases. Okay, now we just need to do one more question. Now notice that the page from before, when we asked you to solve, we forgot to highlight this, is that the angle they want you to find is between 0 and 360. Right? Example 41, 0 and 360 in the first 4 quadrants. But sometimes the question will not be 0 and 360. Sometimes they want to include some negative angle between 0 and 180. And what do I do there? That doesn't change the way we do the questions, just change your answer. So let's do an example. Let's say we'll do this one. Sine square x equal to 3. So we divide both sides by sine 4, like this. And how do I get rid of the square? We have to square root. But when we square root, make sure you put plus and minus. Square root of 3 over square root of 4. Yes? And then square root of 3 is square root of 3 plus square root of 4 is 2. Like that. Plus and minus. So what does that tell you? It's in all the quadrants, everywhere. But they all have the same related angle. Because if you do related angle, you go sine inverse of root 3 over 2. Like that. And then how do you do that? You just do it on a calculator, shift sine. But if you know the exact value, you know it's going to be 60 degrees. So 60. So 60. 60 there, 60 there, 60 everywhere. Right? So after we do this, we have to find the angle x. Now this is where, that's where it affects. So everything else is all the same except this. That's where it's going to affect your answer. So between 180 and negative 180 means that I could still go 60 in the first quadrant, or 180 minus 60 in the second quadrant. But I can't go beyond that. That's going to be more than 180. So what do? I go back. I get negative 60 because it's going to be negative. I can't go more than 180. Has to be, if it's more than 180, have to go negative angle. Okay? And the next one, if I want to go to this quadrant third, I can't travel. Let me use a magic pen. So I can't go this. That's illegal now. I have to go that way. Right? So now we'll go back to the normal pen. So we have to go one negative, but 180 minus 60. So you end up to be negative 120, negative 60, 120, and 60. All right, get the idea? So really need to watch this domain. So everything else is the same, except we change the final answer. I think I've been speaking for too long, so I'll leave this for next time. And then you could try some of the homework from the textbook. I think that's it. Okay, if you